Have you ever thought of the chemical makeup of nail polish before giving yourself a manicure?
On today's episode of I Cannot Believe It's Chemistry, we're going to take a closer look at the chemistry side of nail polish and nail polish remover. There's a lot more science behind the art of painting your nails than you may think. Nail polishes from you to choose from, such as gel and acrylic. But right now we're going to focus on the ingredients in your everyday nail polish, such as this one. The main ingredient in nail polish is a highly flammable compound known as nitrocellulose, which is a film-forming polymer dissolved in either butyl acetate or ethyl acetate. These are both solvents. Solvents are the liquids used to mix the other ingredients in nail polish together to yield a final product. After the polish is applied to the nail, the acetate solvent evaporates, and the nitrocellulose creates a shiny film, which is the reason why nail polish appears to be glossy when it dries. It is recommended that you use both a base coat and a top coat on your nails to protect them from discoloration. The continuous exposure to pigments has a negative effect on your nails over time. Dyes and pigments add color to the polish. The most recognized pigments are iron oxides and colorants found in paint. So by adding a base coat and a top coat, not only are you avoiding your nails from being stained a yellowish color, you are adding strength to the nails, returning moisture to the nail bed, and preventing your polish from scratching, peeling, and chipping. Film formers and resins work together collaboratively. Film formers are the chemicals responsible for keeping the polish smooth when on the nail, while resins secure the polish on the nail bed. Resins and film formers overall strengthen the polish, but they produce a brittle lacquer in the process. To prevent this from occurring, plasticizers are used in order to keep the polish flexible and reduce the chances of it chipping too easily.
Plasticizers do this by linking two polymer chains together, but increasing the distance between them.
Other ingredients include thickening agents, ultraviolet stabilizers, which help to resist color change when the dry film is exposed to sunlight, and pearlescent minerals, which give the polish a glittery or shimmery effect. Now we are going to discuss acetone nail polish remover. You're probably wondering what acetone is and how nail polish remover works. Well, you're about to find out.
Acetone, the main chemical in nail polish remover, is a clear, harsh-smelling, and highly flammable liquid. It is a solvent capable of disintegrating even plastic.
Your nail polish remover is an organic liquid solvent, while nail polish is a hardened organic polymer. When the remover is applied to the polish, as you can see here, the molecules of the solvent will force their way through the polymer molecules, causing the polish to disintegrate. Nail polish remover has a moderate polarity. Many organic solvents of moderate to strong polarity can dissolve even styrofoam. We are now going to take it to an experiment that we conducted to show this. Here we have your regular nail polish acetone remover, and this is a styrofoam cup, and we're going to be pouring the nail polish remover into the cup to show how it disintegrates the material. As she pours the liquid into the cup, watch the bottom of the cup as it breaks down the bonds inside the styrofoam. Already we see a hole, and now the entire cup is falling apart. That quickly, the acetone remover broke apart the entire styrofoam cup and all the bonds inside. Even a few minutes after the experiment, the styrofoam is still breaking apart and dissolving into the liquid.
So, is this what happens when you apply the acetone onto your nail polish?
Yes, when the remover is applied, the polymer molecules are being broken down, causing the nail polish to disintegrate.
Wow.
So here are the pros and cons of using gel nail polish.
The pros. So, gel polishes are long lasting. They can last a few weeks to even a month or two. And they also have low odor, and there's no chipping or smudging like you have in regular nail polish.
As good as they may look, there are some cons to using gel nail polishes. If not removed properly, they can damage your nail bed. And the UV light, which is used to harden the polish, can emit radiation into your body. There's always a downside to everything good. So what exactly is gel nail polish, you may ask? The use of gel polish has become a lot more popular in the last few years. These manicures are made using a gel product hardened by curing under an ultraviolet or LED light. Once you have painted your nails with the gel polish, keep them under the light for 1 to 3 minutes, causing the polish to harden and cure. Repeat this process with more layers of colored gel until opaque.
So this seems simple enough, right? Well, there's actually a lot of chemistry going on in each and every single nail, starting from the makeup of the gel polish.
Gel nail polishes are formulated with many different combinations of oligomers. So, the oligomers and monomers are also known as the photoinitiators, which comes from the term initiator. They are light sensitive and decomposed into free radicals in order to start this polymerization process. Free radicals can be ions, molecules, or atoms that have unpaired valence electrons, causing a dangling covalent bond. Then the initiator is triggered by an activator, which in this case is ultraviolet light. The ultraviolet light lands on the electromagnetic light spectrum at about 400, and in between X-ray and infrared light. So the photoinitiators absorb UV light and convert it into the energy needed to drive the polymerization process. In gel manicures, this is the UV curing. When the gels are put under the UV light, this process takes place, and the oligomers and monomers in it that are in the photoinitiator harden. So the photoinitiator gets its energy from the UV light so that the molecules can't move anymore, and they have to be still, therefore forming the gel nail. In simpler words, the polymerization process is when all the little molecules in the gel are going crazy and moving all over. When they get put under the UV light, they can't move anywhere, making the gel harden. Now, to end the show, we're going to answer some frequently asked questions that were submitted by some of our viewers. So for the first one, was submitted by @shenanigans24. Oh wait, that's me! So I'm going to answer myself. Why and how does nail lacquer dry? Once applied to the nail bed, the polish is exposed to the air, and then the solvent evaporates, turning the liquid nail polish hard. This is the reason why the nail polish hardens if the bottle is left open too long. However, if a solvent such as acetate is added back to the polish, it will become a liquid again.
We have another question from I'm an Acetone. Is it true that the radiation let off by the UV light when curing gels can be harmful? With all the radiation, there is a risk of cancers if exposed in large amounts. But since the UV light used in the process is very minimal, and most only get gel manicures once a month, there is no great risk. You are most likely exposed to more radiation from the sun on your trip to the nail salon than your manicure itself.
So our next question is from @50shadesofpolish. Why does nail polish smell? Well, when the ethyl acetate and butyl acetate combine, they produce a very strong, almost nauseating smell.
From Breaking Bonds, I heard that some nail polishes have ingredients that are proven to cause cancers, like formaldehyde. Is this true? It is true that some nail polishes have carcinogens, but as the nail industry grows, people are finding more ways to make healthier nail polish. Today, most nail polish companies have completely gotten rid of these carcinogens in their products. There are even some all-natural and organic nail polishes in the market. The best way to stay away from these chemicals is to simply read the ingredients on your polish bottle before purchasing.
You know, Isabel, it really is amazing how much chemistry is all around us in our everyday lives, even on the tips of our fingers. So thank you for watching. We really hope you learned a lot about nail polish and its link to chemistry. Bye!